All right, today we're going to dive into a classic engineering story from Zerodha, who, if you don't know, is India's largest stockbroker. It's a fantastic tale about a clever tool built to make things simple that ended up creating a huge crisis. And funnily enough, the story of how a much more complex solution actually saved the day.
So, let's set the scene here. We're not talking about some small startup. Zerodha is processing millions of trades every single day. In this kind of high-stakes environment, speed isn't just a nice-to-have, it is everything. Every single trade request comes in and hits their main system, called the OMS, or Order Management System.
Now, the big enemy in a system like this is latency. It's really just a fancy word for delay. You click buy and there's a tiny pause before the system responds. But at Zerodha scale, even a minuscule delay on one order can cause a massive traffic jam for every other order waiting right behind it. And the problem was that their main system was getting totally bogged down doing all these complex checks on every order that came through.
So right there, that was the big challenge for the engineering team. How in the world do you check millions of orders for all sorts of compliance and risk rules without grinding the whole system to a halt? They basically needed a way to check everyone's ID at the club door before they got inside and clogged up the whole dance floor.
Their first idea was to build a separate component they called Veto. The thinking was pretty smart. Offload all of those initial checks to this service. Let it reject all the bad orders right away so the main system only has to deal with the good ones.
So, think of it like this. The main system, the OMS, is the super busy kitchen in a restaurant. And Veto is the bouncer at the front door. Veto's only job is to check every single order against the list of rules. If an order doesn't look right, it gets turned away on the spot. It never even makes it to the kitchen. It's a brilliant way to reduce the load on your most critical system.
Now, to let their non-technical risk management team write all these bouncer rules, they built Veto using something called a domain-specific language, or a DSL. A DSL is like the language you use to order a coffee. It's super specific and perfect for that one task, but pretty useless for anything else. Zerodha's DSL was basically like writing formulas in Excel. It seemed perfect. You know, simple, familiar. What could possibly go wrong?
Well, as it turns out, a lot. That simple tool that was meant to empower the risk team, it started to fail, and fail badly. And not because of some technical bug, but because of real-world human usability problems. The simplicity they had aimed for, it had become a cage.
As the business rules got more and more complex, those simple Excel-like formulas turned into these unreadable monsters. I mean, just imagine trying to find a mistake in a single formula that's 100 lines long, and it's just a giant chain of ands and ors. You couldn't even use variables to reuse a value. You couldn't give users a helpful error message. And the real kicker, anytime the risk team needed a new function, an engineer had to get involved, build it, and deploy it, which completely defeated the whole purpose of the DSL in the first place.
So the team realized they were in trouble. They were accidentally building a whole new, complicated programming language on top of this simple little engine. It just wasn't working. It was time for a hard pivot. They went all the way back to the drawing board to find a real, scalable solution.
The first thing they did was benchmarked a bunch of alternatives against their old engine, which was called GoValuate. And the results, which you can see right here, were, well, they were stunning. The chart shows nanoseconds per operation, so a lower bar is way better. You can see their old system, GoValuate, and another option, Rego, way over on the right. But just look at the far left. Native Go plugins were the undisputed winner. The performance just blew everything else out of the water.
That performance data pointed them to Veto version 2. The team made a bold decision: rebuild the entire system from the ground up, this time using native Go plugins. This was a radical change. The risk team would no longer be writing in some clunky custom language. They'd be writing their rules in actual Go code.
But to keep things from getting chaotic, they created a simple but really powerful framework. Every single rule written for Veto v2 had to have 3 specific functions. First, a slug, which is just a unique name. Second, a validate function, where the actual rule logic lives. And third, and this is the truly brilliant part, a test data function.
This new approach completely unlocked things they just couldn't do before. Now, with the full power of Go, a simple if statement could check an order, reject it if needed, and, critically, provide a clear, custom error message right back to the user. This was something the old, simple DSL was totally incapable of, and it made a massive difference for everyone involved.
And here is the real genius of the new system. By forcing every single rule to provide its own test cases, the framework built its own safety net. This meant a rule literally had to prove it worked correctly before it could ever be deployed into production. This massively reduced the need for developers to babysit the process and gave everyone a ton more confidence that the system was stable.
Okay, so native Go plugins seem like the perfect answer, right? Well, not so fast. The team picked a really powerful tool, but it came with a list of very tricky, well-known problems. So this is where we get into the real senior engineer level details. Yeah, using Go plugins in production is notoriously difficult. The Go version and all the dependencies have to match perfectly between your main program and the plugin. But the two biggest headaches are these. You can't unload a plugin once it's in memory, and you can't load the exact same plugin file twice, and that creates a huge problem for a system that needs to update rules on the fly.
So let's just frame that first challenge. The risk team just updated a rule. How do you load the new version if the old one is stuck in memory forever, and Go refuses to load a file that it thinks is identical? I mean, it sounds like an impossible situation, right?
The team's solution was an incredibly clever hack. Before any rule gets compiled, a script automatically injects a tiny piece of code, a constant, that contains the current time, all the way down to the nanosecond. This one simple addition means that even if the rule's logic is identical, the final compiled file is technically unique every single time. As far as Go is concerned, it's a brand new plugin, and it loads it up without any complaints. Problem solved.
Okay, here's the second major challenge. To be more efficient, they bundle a bunch of different rule files into a single plugin. But remember, every rule file has a function called validate. So when you combine them all, how does the program know which validate function belongs to which rule? You get what's called a function name clash.
This solution is even more advanced. They use the tool that talks to Go's abstract syntax tree, the AST, which you can just think of as a tree-like map of the code itself. This tool programmatically goes through the code before it's compiled, finds every function named validate, and renames it by sticking the rule's unique name on the front. So validate becomes something like EA sample rule validate. This guarantees every single function in that final plugin has a totally unique name. No more clashes.
And this really brings us to the powerful lesson the team at Zerodha learned. They found that instead of trying to build a simple, custom tool that just created more problems down the line, it was actually better to trust their operators, give them a real, powerful tool like the Go language, and then build a super strong framework around it to keep everyone safe.
So, the final thought I want to leave you with is a question we should probably all ask ourselves about our own work. It's so tempting to build a simple, custom little tool for a specific problem, but as Zerodha's story shows, you have to ask, at what point does that simple tool start causing more headaches than it solves? Sometimes the better answer is to trust your team, embrace the power of a real tool, and just focus on building a great framework that makes it safe and effective for everyone.